Okay. Today we will have the application of the percentage problems, and we will solve a percentage word problem. Here we will have a hero called golden plover. It's a small bird, and we will see. In fact, this subject is a little bit related to the 4th grade subject sequences. But I think you can understand, using percentage, we can solve our energy problem. So, let us start. This is our hero. It's called golden plover. So, before solving the problem, energy problem, let's take a look at some basic facts. About our hero, bird. First of all, it is a very small bird, size of a dog. You know what's a dog. So, very small bird, size of a dog, and it's the real photo of that bird, golden plover. And the second thing is, unfortunately, it is not a swimmer. It cannot swim. It's really important for our problem. You will see the problem, energy problem. And the average weight is 130 grams. The average weight is 130 grams. So what's the problem here? We will solve the energy problem. So, in a summertime, our bird lives in Alaska. Somewhere here. In the summertime, our bird lives in Alaska. But the wintertime, golden plover migrates from Alaska to, do you know this place? Hawaii. But this, distance, is, of course, it's not easy because it's covered at 4,500 kilometers. 4,500 kilometers. Flies from Alaska to Hawaii, as I said before. What's the reason why this bird migrates from Hawaii to winter? You know the reason, because it's the summertime, everything is okay, they can find the food, but for the winter time it's difficult to find the food because of they fly from Alaska to Hawaii. Why they are not choosing, another place somewhere here? We don't have the explanation. We don't know the reason. So, the important thing is, it's related to our problem. This flight takes 88 hours. 88 hours from Alaska to Hawaii. Non-stop flight. Non-stop flight. Without eating, without sleeping, without taking any other energy food. So 88 hours. And stop for rest is impossible. Why? As you can see, there is no land between Alaska and Hawaii. And they cannot swim. So it's a non-stop flight. 88 hours. And it takes 3 days, 4 nights, non-stop flight. 3 days and 4 nights. Unbelievable. And 250,000 wing flaps or beats. Wing flaps. 250,000 wing flaps. Try to imagine. So 88 hours, you are flying 88 hours from Alaska to Hawaii. You cannot sleep, you cannot eat anything, there is no place to rest. So it's a non-stop flight. So now we will have 2 problems here. In fact, we have 2 questions here. First question is this. How do they navigate? We won't take a look at this question. In fact, we don't know the answer. So how do they navigate? How do they, where to go? How do they get there? And why this island? And how do they navigate? Do we have an explanation here? What is the explanation? What?
Using the stars.
Possible. But the scientists, of course, they search this, but unfortunately, nobody knows for sure. We don't have the logical explanation. And of course, they are still trying to figure out this, but we don't have the logical explanation for the first question. What's the second question? How do they navigate? We don't know the reason. So the second question is, it's related to our subject. How is the bird capable of flying this distance? I mean, energy problem. Of course, if you are going from Alaska to Hawaii, you need energy, you need fuel. So, how is the bird capable of flying this distance? For the second question, mathematics will help us. Mathematics will give you the answer and logical explanation. So, we can explain the second, we can give the answer of the second question. So, today we will take a look at the second question, and using our previous knowledge, percentage, we will solve the problem. And just for the comparison, this is our bird, 88 hours, non-stop flight. This is the airplane, as you can see, and its record is 18 hours. Of course, without taking fuel. So, at most 18 hours, you can fly with the airplane at most 18 hours, but this bird can fly 88 hours, non-stop flight. And because of that, at the beginning I said it's our hero. So, what about the problem, our problem? Now we will solve the problem. But first of all, I should give you this information, because without using this information, we cannot solve our problem. Flying for 1 hour, the bird uses up 0.6% of its body weight. Its body weight. Of course, scientists gave us this percentage. Now, golden plover energy problem. Today, we will try to solve this problem. But remember, we have some data, information, which are given to us. So, let's take a look at, let us remember the question. Now, our question is this: from Alaska to Hawaii, cover 4,500 kilometers journey. So, golden plover flies from Alaska to Hawaii. And this flight takes 88 hours, non-stop flight. The bird's starting weight, we will use G0, is 200 grams. It's something interesting here. Before the flight, our bird takes some, just eating and take fats for the fuel, for the energy. 70 grams, extra 70 grams for the flight. The bird is preparing for the flight. Extra 70 grams, just eating, last 2 weeks, eating and eating, nothing else. And before the flight, its weight will be 200 grams before the flight. And 70 grams here. And by the way, if the weight of the bird is smaller than, if it is less than 130, unfortunately, our bird will die. It will die. So it cannot be smaller than or less than 130 grams. So starting weight is 200 grams, but 70 grams are stored as fat to be used for fuel. And flying for 1 hour, the bird uses up 0.6% of its body weight. This is our question. Now, we will try to solve the following problem. The starting weight is, we said G of 0, it's what? 200 grams. And using our mathematical knowledge, we will try to find G of 88. What is the meaning of G sub 88, or G of 88? Yes, after 88 hours, what will be the weight of our bird? But consider this knowledge, this information, we have 70 grams of fuel. If it is more than 70, so it will die. It will down to the ocean. So, can you find the G of G88, and after 88 hours, what will happen? What will be the weight of our bird? We will use the information which are given to us. 4,500 kilometers, it's not important at the beginning, but the important thing is 0.6% of its body weight. So G of 0 is given. First of all, we should find G of 1. How can I determine the value of G of 1?
200 grams minus 0.4.
200 grams minus what?
0.6.
By the way, what's the meaning of G of 1?
1 hour.
Up to 1 hour. It will be the weight of our bird.
199.4.
Yes, but how can I get that number? So remember, for each hour, our bird uses up 0.6%. What was the starting weight? 200 times what? 0.6%. But you should write that percent in this form.
Yes.
So it gives you G of 1. Maybe we can write this in this form, 200 minus 200 times 0 point what? 0.06, is it? If you divide by 100, it will be G of 1. What about G of 2?
G1 minus.
Yes, it will be what? G1 minus what?
Minus G1 times 0.6.
Yes, you are right. Minus G1 times 0.6 over 100. It gives you G of 2. But of course, we won't do like that. We will find G3, G4, G4. It's a long journey for us. We will use our math knowledge. How can I get G of 88? We can formalize this. Look at this. Here, you can factor out, you know the meaning of factor out, 200. If you factor out 200 here, it will be 1 minus 0.06. It's G1. And here, you can factor out G1 here. If you factor out G1, you will get 1 minus, it has the same value, 0.6 over 100 gives you 0.006. Here G1 parenthesis, you know the G1. So it's equal to what? Here. G1, substitute the value because G1 is here. It will be 200 times 1 minus 006 times 1 minus 006. So shortly, it is square of this difference. So it's equal to 200 times 1 minus 0.06 squared.
Sir, that means that G88 is equal to 200 times 1 minus 0 times 006 on 98.
98 or 88?
88.
88. Yes, you are right, James. So, after the second hour, its weight will be this. It can be found using this formula. After 88 hours, like Jenny said, it will be 200 times 1 minus 0.006 to the power 88. For each step, look at this, we will multiply by this difference. It will be the result. Do you have a calculator? Can you evaluate this? Let us evaluate this. If you have a calculator, evaluate this. 200 times, it's what? 0.994 to the power 88. Just evaluate this. This is G88. What will be the result?
But it is
It is 0.5888. That 0.994 should be 88.
Yes, if you multiply by 200, what will happen? I know the result, but
107.
so let us round that number.
Yeah.
So if you round that number, 117.8 grams. Approximate value is this. But something is strange here.
Our hero should have died.
Yes, it must die. Why? 88 hours later, its weight will be 117.8. So let us find the total energy. I mean, this word consumed. Let us find. At the beginning, 200. Remember, 200 minus 117.8. What's the total fat here?
Times 3.
It will be what? What is the result?
82.2.
80.
82.2.
But remember the question, we have 70 grams, stored as fat to be used for fuel. But this bird needs 82.2 grams of fat. Otherwise, the bird cannot reach its destination. Remember, Hawaii. So how can you explain this? Of course, we have the explanation here. Can you guess?
Yeah.
Tell something. How is this possible?
She generates energy in that way.
So of course, we have 70 grams of energy. So something is decreasing the consuming energy. We have two things here. We have two important things. First thing is, now you will see, we did this calculation. So we did it. So body weight after 8 hours. So after 88 hours, it will be 117.8. So fat uses as fuel after 8 hours. We did it. After this calculation, we got the result. But how does it do that? First one is speed, I think. Flying speed. It's really important. What do you think? Should the bird fly slowly? Or fast? Or constant speed? If the bird flies slowly,
Constant speed.
just air resistance. Remember, air resistance, so it will consume more energy. And if you fly fast, then again, because of air resistance, so you will consume more energy. So the best choice is a constant speed. Just imagine yourself, you are running a marathon, 40 kilometers. So what will you do? You will run fast, or slowly, or constant speed. The best idea is constant speed. But what's that speed? Constant speed. Which speed?
51.
The scientists gave us the answer.
51.
It's 51 kilometers per hour. So this bird knows the constant speed and at a rate of 51 kilometers per hour without changing its speed. But unfortunately, it's not enough. 88, yes, of course, he will gain some more energy, decrease the energy consumed here, but we have 12.2 grams difference. 70 grams, we have 70 grams, but this bird should consume 82.2 grams. There must be something else. Maybe this video helped us. Let us watch the following video. I think you will give the answer. They are not golden plovers. They are the flock. Do you know what's a flock? Geese flock. Group of birds. It's called flock. Yes. So they are not golden plovers, but they are doing the same thing. What's the second thing?
Maybe wind.
Yes.
No.
The formation.
Maybe the formation. Flying.
Yes, you are right. Second thing is formation, flying formation.
We got the
But what's that formation? What's it?
the narrow.
V. Yes. That V formation. So this formation, V formation is the second answer. I mean, that formation is used by geese and the other birds. They are using the same method for gaining energy, extra energy. So, of course, again, scientists, they evaluated everything, calculated everything. This V formation helps the birds. Of course, they have alternate leaders. Alternate leaders. What does it mean, alternate leaders? What does alternate? Yes, they are changing their place. For example, now this one is a leader, but maybe after 1 hour, maybe 50 minutes later, the second one will be a leader. So alternate leaders. And this bird, this flying formation, blocks the air resistance and cuts the energy here. So this V formation gave the golden plover birds 23% of energy gain. Flying in V formation saves 23% of energy. So, in fact, it was the answer of our question. Yes, normally they should consume 82.2 grams of fat for the fuel. But they have 70 grams. They have 70 grams. If they don't know this formation, or I mean the constant speed trick, they will die before 800 kilometers to Hawaii. So they have enough energy for 72 hours. But 88 hours non-stop flight. We have 88 hours non-stop flight. So using this trick, V formation saves 23% of energy, and the second one is 51 kilometers per hour, constant speed. So they can reach their destiny. And they are using 70 grams. In fact, they are not using total 70 grams. They have some extra amount of energy. Why? Because of the wind, unexpected happenings. they have some extra energy. Maybe they are using 65 grams or 66 grams. Of course, these are the approximate values. But they are evaluating, calculating everything without, before the flight. And they are eating and they are gaining extra 70 grams for the flight. And they don't know anything. I mean, where is Hawaii? They are not using satellites, navigation tools, nothing. And they know, and they are going somewhere where they haven't never been before. In fact, these birds are the golden plovers. Let's take a look at our birds again here. So our bird laying eggs, and after 25 days, so chicks, you know, it's a chick, and they are going. I mean, the father and mother, they fly from Hawaii to, Alaska to Hawaii. But what about the youngs, chicks? Next year, they will go to the same place. But they have never been there before, Hawaii. And one more interesting thing about this flight, Hawaii Islands discovered before 1000 BC. Polynesians, they discovered that island. But how they discovered?
They follow the
Yes,
birds.
by following these birds. They saw the birds. They are flying somewhere, and they know that non-swimmers. So there must be something here, land. So 400 years they follow these birds. And then they discovered Hawaii Islands. 400 years they followed the birds, golden plovers, and they discovered Hawaii Islands, 10,000 BC, Polynesians. So that's the interesting fact about the golden plover. Do you have any question here? So this is the amazing bird, amazing creature, and it's a great migration. If you watch National Geographic, there's a documentary program, Great Migration. One of them is this. And salmon fish, another great migration. But the length is 4,000, the distance is 4,500 kilometers. Of course, it depends on your starting point. Approximate value is 4,500. It may be greater than 4,500 or smaller than 4,500. It's a great flight. So they are saving their energy, and they are using V formation like other birds, like these. And this is the end of our problem. We solved our problem using math here. And do you have any question about this problem? Did you understand this calculation here?
Yes.
Everything is clear?
Yes.
It's a mathematical calculation. But what about the birds? I mean, of course, maybe no math, and calculating I will need 66.8 grams of fat, so I should eat more, or reformation, constant speed, sometimes 51 kilometers per hour, or sometimes 55 kilometers per hour. We don't know. As I said before, for the first question, maybe the second question we gave the answer, but nobody knows for sure for the navigation problem and the second problem. But this is our explanation, mathematical explanation is here. It's logical explanation. So they are gaining extra 12.2 grams using V formation and constant speed trick. So that's it. What other question? Okay, thank you very much.